exists only one, so it means that in that particular stream, we have only one reactant. Okay, 100% reactant. Okay, it is given to you, use the fluid package as pyromycin. Okay, the flow rate or the molar flow rate given is 100 kilogram mole per hour. Okay, the objective is to evaluate the phase stream from V over F information. Okay, vapor phase fraction. Okay, case 1, set the V over F equivalent to 1. Okay, in case 1, we are going to look what is the dew point look like. Okay, class, what is the dew point? If you still remember what you have learned last semester, what is dew point? Anyone can help me to answer? What is dew point condition? Anyone can try? What is dew point? What is the condition that we call as dew point? Dah tak ingat dah? Lupa dah. Last time you ada belajar kan? Dew point, bubble point. You have learned in plant design, especially in designing your distillation column. Okay, you deal with dew and also bubble point. What is dew point, class? Anyone can try?
The temperature and pressure at which the liquid starts to condense.
So the phase is from liquid to?
It's from vapor to liquid.
Okay, Akasha? Okay, from liquid is about to?
From liquid to vapor.
Can you repeat again? Okay, liquid, okay. So it is the point actually when the liquid is about. Yes, dew point. It is about to change to dew point. Okay, good try, Akasha. Okay. Okay, so we go to the first one. Case 1, V over F equivalent to 1. Okay, when the pressure is 1 atm, what is the temperature and phase of the stream? Okay, let's look. Okay, I'm going to share the screen. Okay, semua tak ada masalah buka HiSys. Ada siapa ada masalah dengan AnyDesk? So far okay?
Okay.
Okay. Kalau ada problem tiba-tiba terlog out ke ataupun tak boleh masuk, bagi tahu saya because kita ada standby IT technician dekat lab. So he will look into that particular PC if let's say you have problem. Okay, so let me share the screen. Okay, so this is my screen. Boleh nampak Kelas, boleh nampak screen saya?
Boleh.
Okay, so I'm going to start with this. Okay, so the HiSys that we are going to use is the Aspen HiSys version 11. So when I double click this, usually it will take some time because they have to load all the calculation, the formulas from the system. So it quite take maybe 1 or 2 minutes. Okay, if let's say I double click here, you will get like this. Okay. So this is what you're going to have, and then since we are going to do new exercises, so you just click new. Okay, so what what you can see is that, okay, at the left hand side, you have the component list. It means that our reactant and also fluid package. So these two is the most the basic thing that you have to remember. Whatever the question that they give you or whatever the assignment or lab session that you have, okay, focus on these two only. Okay, this is the main thing when you start to do the HiSys. Okay, component list, it means that the reactant involved in the stream. And last, the next one is the fluid package. Okay, the other 4 things here, this one, we will look into this in the later lab exercise. Okay, maybe in week 4, week 6, 7 and 8. Okay, after you punya ni lah. Okay, you punya presentation. Okay, so the first thing is that what you should do, okay, I have the component list and also the fluid package. So if you notice, the left, I just want to mention to you, apart from having at the left hand side here, we also have the component list as the symbol at the top here, and also fluid package. Okay, so you just focus on these two for at the moment. Okay, and then so if you click here, we have the properties and simulation. Okay, so the first one we have the properties. You double click or you just click one for component list, and you will have the add button here. So I just click add. Okay, so I have the select pure component. Okay, and then kita ada search for. Okay, untuk filter dengan search bar ni, you just default saja dekat sini. So what is our reactant tadi? What is our reactant? Reactant is water.
Only
So
water.
you just type water. Okay, water. You just type water. Okay, so water exists as a pure component. Okay, so cara dia sama ada you double click H2O ataupun you just click once atau then you click add. Sama saja. Contohnya saya double click. Okay, so dia terus masuk. Okay, water as the pure component. Ataupun tadi, this is the first way. You double click and then it will automatically appear. Or you just click once, water, and then click add. Also can to the left hand side. So far okay? Class, so far okay? Okay, please respond sebab kalau tidak saya tak tahu you boleh follow ke tak. Kalau saya laju, you beritahu Okay, so once you double click here and you can see the water at the left hand side, you will see the status is okay, green color. Green color means it is converged, or in other words, your selection is correct. Okay, if appear red or grey, yellow color, something is wrong with your system. Okay. Okay, so the next that one is component list. Okay, so once it is converged, dia akan keluar sebagai component list 1. Okay, the next part, second step is to click fluid package. Okay, so you nampak dia masih dalam properties and then click add. So what is the fluid package in our question just now? It is Robinson. So you just click add. Tadi saya add, lepas tu saya pilih Robinson. Okay, ini boleh nampak Okay, kelas boleh nampak Robinson?
Boleh.
Okay,
Boleh, madam.
so you double click, then it become green color. It is okay. So you notice that once you selected fluid package, so it will appear all the properties and calculation needed in the question. So sebab tu the choices of the fluid package is very important, sebab bila you click the fluid package, all the calculation equation will come together as in one package. So inilah semua ni Okay, so now once it is converged, so the next step, the third step tadi first step, key in the component list ataupun reactant. Second step, click the fluid package. Next, go to simulation. Okay, can you see the simulation? Okay, so for your information, okay, ini yang putih ni kita panggil flow sheet Okay, and then you notice that we have the small box here called as model palette. Biasanya box ni kita akan drag ke kanan Okay, so that your work later akan lebih mudah lah. Okay, you just put aside to the right hand side and you will have a spacious flow sheet here for you to drag all the stream and also equipment. Okay, what do you have in the model palette here? Model palette we have streams. Blue color is the main stream, okay, in the plant. Red color is the energy stream. Okay, kalau macam contohnya equipment tu ada heat supply, okay, contohnya reaktor ataupun heater ataupun cooler, okay. And then the rest ni semua ni kalau you nampak ini adalah contoh apa, the first one mixer, okay, kita ada splitter, kita ada heater, cooler, then kita ada separator, okay, there are many more, okay, kita ada reactor, separator and so on okay, and then pump also ada, okay. Okay, now back to our question. What is our question just now? Okay. Okay, to evaluate the phase of stream from V over F information. Case 1, set V over F equivalent to 1. Okay. So when you want to start with the high seas, okay, when we talk about high seas, we know it is about the plan, right? So the plan apa-apa pun mesti akan ada inlet stream. So what I do is that I just click once on the stream and then drag. Okay, again, click, drag. Okay, are you following class?
Hello.
Boleh, Madam.
Yes.
Okay, so click and drag. Make sure you click the blue stream sebab blue stream adalah main stream. Okay, once you have drag, double click on the stream and then kita akan nampak the yellow color here. Okay, so you just follow the instruction. Yellow ni selalunya instruction lah yang kurang ataupun tak cukup. So the first one, kalau kita nampak kita ada condition, kita ada properties, kita ada composition. So yang tiga ni lah yang paling utama Okay, so let's go back what they want. Unknown composition. When they're asking for composition, so it means that go to composition. Okay, macam tadi ni condition kan, condition, properties, and then okay, so kalau you tengok condition, kita ada vapor phase, fraction, temperature, pressure and so on. If properties, semua ada molar mass, okay, molecular weight, mass enthalpy. Okay, but since they are asking for unknown composition, we go to composition tab. Okay, you notice that we have the water because tadi you dah masukkan water, right? So what is the mole fraction? Okay, here is the rule. Usually kita takkan guna mole fraction sebagai by default kita akan guna mass fraction unless the question give you mole fraction, then only you choose the mole fraction as the basis. Okay, but for this case dia tak mention apa-apa pun pasal mole fraction ke apa, so by default kita akan change kepada mass basis. So how to change the basis? Because this one is mole fraction, I want to change to mass fraction. So how to change? Go to basis. Okay, so kita ada banyak kat sini, mole, mass, mole flow. So kita akan choose mass fraction. Okay class, are you following?
Yes, Doctor.
Okay, so I choose mass fraction. Okay, and then I close. Okay, and then next one, double click this. So you nampak double tukar just now is mole fraction, right? Okay class, boleh?
Boleh, Doctor.
Okay, so once it change to mass fraction, you double click the empty. Empty means you can key in the value. Okay, so I just click once. Okay, what is the mass fraction? Since we have only one component, so of course it will be as this as 100%. So the mass fraction is 1. Is it right class? If I have only one component means 100%, right?
Yes, Doctor.
Yes.
Okay, so the 100% means the mass fraction is 1. Okay, you key in 1 and then you enter. Okay. So once you enter, dia akan pop up this window. So apa kita nak tengok dalam window ni? Okay, you have to check. Okay, you have chosen, you have changed to mass fraction. Okay, 1. And then dekat composition basis pun, okay, already changed to mass. Yang ni paling penting total is 1. This is very important. Kalau you ada banyak sekalipun composition, dia mesti total sama dengan 1 sebab mass fraction. Okay, so if this is okay, mass fraction 1, chosen with mass fraction and then total is 1, then you click OK. Okay class, are you following?
Yes.
Okay, when I click OK, okay, so yang ni maknanya you punya ni dah okay. So nampak tadi dia minta composition, right? Okay, tadi once you dah click OK, so dia minta the next input. What is the unknown temperature? Okay, unknown temperature nak bubuh dekat mana Okay, tadi kita dah settle untuk composition. Okay, so temperature, pressure semua tu dalam condition. Okay. Okay, boleh? Okay, dia ada bagi tahu tak temperature berapa? Ataupun dia asking for temperature? Oh, dia asking for temperature. Dia asking for temperature and phase. You are given only V over F equivalent to 1 and P 1 atm. Okay, so for this case, as a rule of thumb, yang paling penting untuk condition ni you nampak ni, V vapor pressure ni adalah V over F, temperature and also pressure. So as I mentioned in the first class, out of these 3 parameters, okay, you are required to fill up only 2 properties only. Contoh, sama ada vapor phase fraction dengan temperature, atau vapor phase fraction dengan pressure, atau temperature dengan pressure only. Because if let's say you specify all these 3, HISIS akan define sebagai over specified. Okay, clear Okay.
Yeah.
Let's say kalau saya contoh untuk soalan ni, saya masukkan vapor over phase pressure atau V over F dengan pressure. So automatically dia akan calculate what is the temperature. So sebab tu you just cuma masukkan 2 parameter saja ataupun properties, dan properties ketiga tu dia akan auto calculate. Okay, that is why you cannot key in all the 3 parameters, because then the third parameter will be automatically calculated based on the 2 parameters yang you dah key in. Okay, okay class, how about molar flow, mass flow? Yang ni yang bawah ni molar flow dengan mass flow ni you kena key in. Okay, so sometimes they give you molar flow ataupun molar flow rate, sometimes they give you the mass flow rate. So it depends. So yang ni kena masukkan lah salah satu. Okay, and then how about the standard ideal liquid molar enthalpy? Okay, once you dah masukkan 2 parameter yang atas tadi tu, yang saya kata 2 out of 3, all the parameters starting from standard liquid flow, volume flow, molar enthalpy semua ni, dan juga di properties here, semua akan auto calculated. Okay, so jangan risau macam contoh tadi you dah pilih H2O. See, this is molecular weight for water 18.02. They have calculated for you already, and then some of this also dah calculated. Let's fill up the condition just now. Okay, V over F equivalent to 1. Okay, so cara dia, you just click sekali saja, masukkan 1 and then enter. Okay, are you following?
Yes.
Okay, what is the pressure? Temperature 1 atm. Okay,
ATM.
cara dia masukkan 1 and then make sure you check the unit. Okay, be careful on the unit. Sometimes the unit dekat sini tak sama dengan apa yang kita nak. Some of the PC ni dia tulis kat sini bar. So make sure you change the unit here. So now since they're asking for 1 atm, make sure I choose 1 atm and then enter. Okay, nampak semua dia calculated. Okay, so back to the question. If let's say I set V over F equivalent to 1. Okay, and then, V over F equivalent to 1 and pressure 1 atm. What is the temperature and also phase? Okay, what is the temperature?
99.96 degrees Celsius.
Okay, good. 99.96. What is the phase now?
Vapor phase.
Sebab kita ada 2. If vapor phase equivalent to 1, it means that the stream contain 100% of vapor phase. Okay, if echo phase equivalent to 0 ataupun vapor phase equivalent to 0, dia adalah aqueous phase ataupun liquid phase. Okay, so obviously bila you nampak vapor phase 1, aqueous phase 0, maknanya dalam stream tu aqueous tu tak ada. So yang ada cuma vapor phase sahaja. Okay, boleh senang tengok macam ni kalau aqueous phase tu maknanya liquid phase tu tak ada zero. So yang exist cuma vapor phase. Okay class, are you following?
Yes.
Yes.
Okay, semua dapat 29.96. Okay, so the next one, what if this time you change the pressure 10 atm? So cara nak tukar senang saja macam tadi, go back to pressure and then tukar pada 10, make sure the unit is correct and then enter. Okay, so now you see that the temperature is changing 180.6 degrees C. Okay, dapat semua 180.6?
Dapat.
Okay, so the phase is
Vapor.
vapor also. Okay, okay, good. So far so good.
So far so good.
Okay, what if you change to 0.5 atm? Next question. Okay, simply change 0.5. Make sure you check the unit first before you enter. Okay, so bila you tukar, bila enter terus dia keluar 81.68. And also still exists as vapor phase. Okay class, any questions so far? Class, any questions so far?
No.
No, Doctor.
Okay, good. Okay, can I proceed to the next question?
Yes.
Okay, sebelum tu, case 1. In your opinion, what are these condition called? Okay, dia adalah dew point condition. Okay, case 2. Case 2 this time, it is for bubble point condition setting. Okay, so at this, in this case 2, you need to change the vapor over V over F value to 0. Okay, pressure masih sama macam tadi 1 atm 10 dengan juga 0.5. Okay, let's do together. Okay, so now we go to V over F. Okay, saya klik balik V over F, change to 0, enter. And then pressure saya 1 atm. Check unit, saya always check the unit. Okay, so now the temperature change to 99.96. Okay, dapat semua?
Dapat.
Okay, what is your phase now?
Aqueous.
Yes.
So you notice that tadi dekat sini kolom ni dia tulis vapor, right? Yang sebelah tu
Yeah.
aqueous. Okay, so sekarang ni sebabkan this stream contain aqueous ataupun liquid phase, so dia dah berubah. Okay, tapi you nampak now the aqueous become 1. So it means that this stream contain 100% liquid ataupun aqueous. So there is no vapor stream in the there is no vapor phase in the stream. 0. Okay, what if you change to 10 atm? What will be the temperature? Change to 10 atm.
180.6.
0.6. Okay. Check. Good. 180.6 and the phase is
Aqueous.
aqueous. Okay, good. Okay. Next, change to 0.5 atm. Change to 0.5. What do you get for the temperature?
81.68.
1.68. Okay. Check ATM. Okay, 81.68 Okay, good. So it exists as aqueous. So the condition that we have looked now in case 2 is the bubble point. Okay. So far can I move to case 3?
Yes, Doktor.
Okay, case 3 apa yang dia minta? Oh, sorry. Case 3. Okay. Case 3, still the same. We have water as a component list. We have fluid package, Per Robinson. Okay, flow rate. Oh, saya tak masukkan flow rate ke tadi? Oh, saya tak masukkan flow rate. Tapi sama saja Macam case ni, dia tak berubah. Sekejap, saya cuba masukkan flow rate. Macam mana nak masukkan flow rate Okay, unit given, sepatutnya saya masukkan flow rate juga tadi sebelum case 1 dengan case 2 tadi. Tapi saya tengok untuk case 1 dengan case 2 ni, flow rate ni dia tak effect sangat. Maksudnya you tak masukkan pun temperature masih sama. Tapi sebenarnya as a rule of thumb, you kena masukkan yang 3 tadi tu, 2 daripada 3. Maknanya antara V over F, temperature and pressure you masukkan 2 saja. And then the next yang you kena masukkan adalah molar flow rate or mass flow rate. Okay, so as I mentioned just now, untuk case 1 dengan case 2 ni, walaupun you tak masukkan molar flow rate, dia tak ada effect kepada jawapan. Sebab untuk case ni tapi untuk case lain, molar flow rate ataupun mass flow rate kena masukkan. Okay, okay, saya masukkan because they give you 100 kg more power. Make sure you masukkan betul jangan termasuk dekat mass flow rate. Okay, so kilogram, I just click once. And kat sini 100. Make sure the unit is correct. Kilogram per hour. Enter. Okay. Boleh Okay, so maknanya yang tadi temperature dengan apa tadi? Temperature dengan phase tu tak berubah. Saya masukkan Okay. Okay, go back to case 3. Okay, case 3 masih sama, semua sama flow rate. Okay, this time dia minta you clear dia V over F. Macam mana nak clear? Okay, yang tadi kita buat 1 or 0 right in case 1 and case 2. So untuk clearkan you just click once and then delete. Nampak? Bila you delete dia semua dah jadi berubah. Okay? Okay class? Are you following?
Yes, Doktor.
Okay, delete Okay. So if you deleted, okay, please try to key in the value of pressure and also temperature. So macam saya kata tadi lah, macam case 1 and case 2, you have the information V over F dan juga pressure. So the system will calculate the temperature for you. But this time, you are asked to empty the V over F sebab you nak masukkan pressure dan juga temperature. Okay, clear Kenapa kena clearkan V over F Faham kenapa?
Faham.
Okay, so now I start with number 1. The pressure is 1 atm T 99.5. Okay, biasanya saya akan masuk temperature dulu. Make sure the unit is correct. Degree C, pressure 1 atm. Okay, so the question is, what is the V over F and also phase stream? Okay, what is the V over F value?
0.
0. So it means?
Aqueous phase.
Aqueous. Okay. So kalau you nampak 0 saja, you tahu automatically dia adalah aqueous. Okay, so obviously lah memang ini adalah aqueous. Okay, what if you change the next one? T equivalent to 100. Okay, what if you change T equivalent to 100? Okay, simply change, check the unit, enter. Okay. So what will be the V over F now?
1.
1. And then exists as?
Vapor.
Vapor. Okay, okay, good. Okay, the next, the third question. P 10 atm, temperature 180.5. Oh. Okay, temperature 180.5. Pressure 10 atm. So what will be the what will be the V over F value?
0.
0 exists as
Aqueous.
occurs. Okay. I will give you 3 minutes untuk you habiskan yang question 4 until 6. Boleh buat?
Boleh Doktor.
Okay, sebenarnya jawapan dah ada dalam slide you boleh double check. Okay. Okay, 3 minutes saya bagi. Okay class, are you done?
Dah.
Dah senang Okay, let's just do very quickly. So I have 10 ATM and 180.7. Okay, kita nak tengok if let's say there is a slight change in the temperature while fixing the same pressure, what will become the V over F value? Okay, 180.7. 100. Okay, yang tadi tu adalah V over F 0 and echoes Now we change to 180.7. Okay, so even a slight change also, kita akan berubah dia punya V over F value. Okay, V over F equivalent to 1 and exists as vapor phase. Okay, class?
Okay Doktor.
Okay, then the next one, 0.5 atm and 82 degrees C. Okay, 82 B 0.5 Okay, so this one you akan dapat V over F equivalent to 1 and also exists as vapor phase. Okay, and then we are going to see what if you do the slight change. Okay, you decrease temperature 1 degree kepada 81 degree C by fixing the same pressure. So what will happen? Tadi ni vapor phase okay, 81 and then pressure masih sama. Okay, so you nampak dia berubah. Okay, so it means that even a slight change of the temperature can change the phase of the stream. Okay, ini yang kita akan panggil dew point ataupun bubble point. Okay, but in this case, untuk case 3 ni, okay, soalan dia, in your opinion, when this set condition is called, okay, sorry, what are this set condition is called comparison to set 1, case 1 and case 2? So, jawapan dia adalah bukan T dew dan dia juga adalah bukan T bubble. So, dia adalah in between, okay. So, maksudnya dia adalah condition other than dew point and also bubble point. Okay, class, are you following?
Yes.
Uh,
Yes, Doctor.
okay, good. Can we move to exercise 2?
Yes.
Okay, exercise 2. Okay, how to start exercise 2? Exercise 2 ni lain kan dia punya apa? Component list. Okay. Nak saya share ke dia punya soalan? Ke you dah
Boleh.
buka you punya ni? Okay.
Dah buka juga.
Okay, tak apa. Kita baca together. Okay. Okay, boleh nampak
Boleh.
Okay. Okay, create one stream that contains only N-butane. Okay, I give you 2 minutes to read the question. What do you want? Okay, boleh kita mula?
Boleh.
Okay, create one material stream that contains only N-butane. Contains only, it means again it is a single reactant. Is that right?
Yes,
Class,
Doctor.
okay, so this tadi kita pakai water, now kita pakai N-butane. Okay, you are given fluid package, pyrobenzene, flow rate 100 kg mole per hour, temperature 500 K and also pressure 18 bar. Record the phase, mass density, molar volume, molar enthalpy, mass entropy and also viscosity. Okay, so how we are going to start with this? Okay, saya share screen. Okay. Okay, so ini screen kita tadi So to start with the new HYSYS, what you do is that, okay, you close tadi. Okay, contoh kalau lah kata you nak delete, katalah you tersilap drag component ke atau drag stream, what you do is that you highlight. Okay, are you following?
Yes, Doctor.
Okay, lepas tu you right click. Dan ada button delete dekat sini. Okay, boleh?
Boleh.
Dan you delete Okay, do you wish to delete? Yes. So screen you akan jadi kosong semula. Okay. But now kita tak boleh nak guna screen ni because tadi kita dah set kita punya apa tu component list sebagai water. So what do you do is that you go to file, you go to new and then click case. Okay, cuba buat sekarang. File, new and then case. Okay class, are you following?
Yes, Doktor.
Yes.
Kita tekan case, dia akan keluar balik interface yang asal tadi lah. Macam mana dia boleh terkeluar balik sekejap Sekejap saya start balik. Sepatutnya bila case tu you terus akan keluar yang tadi, yang mula-mula yang you jumpa component list, fluid package semua tu sometimes kalau you tengah buat kerja, buat lab ke atau assignment, kalau dia close balik you just try to login semula. Okay. Okay, so since sebab kita dah buka tadi, saya dah mula daripada asal. Sekejap Okay, so I go to new. Okay. So semua dah ada interface yang ni semula
Ada.
Okay. So again, go the very first step, component list, and then I click add. Okay, so what is our type n-butane, so you nampak n-butane. So what you do is that you double click ataupun you click add. Okay, contoh saya buat n-butane add. Masih dia keluar juga. Ini cara lain dah. Tadi saya mula tu saya tunjuk double click, right? So kalau yang add ni macam tu you guna you just click once and then you click add. Okay, so n-butane pure component. So it is converged, is okay. Okay class, what to do next? We have completed the component list. Next. Anyone can tell me what should I do next?
Pilih fluid package.
Go to fluid package. Okay. Add. What is the fluid package that we want to use? Kat sini macam-macam ada Anton, ASME, Bronchitan, NRTL, semua ada Okay, tadi apa tadi? Kita punya ni? Pan Robinson. Okay, good. So you go for Pan Robinson. Macam tadilah keluar semua properties kat sini and then it is green color converge, so it means it is okay. Okay, finish second step. Okay, what is the third step class? Lepas converge, you have completed already the component list and also fluid package. Oh sorry, ini tadi. Okay, what to do next? Class, what to do next? Go to simulation. Is that right?
Yes.
Yes.
Go to simulation. Macam tadi. Okay. Okay. So now back to the question. Apa dia nak? Okay. They give you molar flow rate 100 kg mole per hour, temperature and also pressure, record all the properties needed. Okay. So what is the first thing? Macam biasa kita kena ada, any plan mesti kena ada input stream. And then they asking for composition. This step sama macam tadi. So what should I do next? Unknown composition. Where to go? Pergi dekat mana? Unknown composition. So okay, go for composition And then you notice that it is stated already, it is a N-butane. Okay, more fraction again. Okay, macam biasa tadi. Tukar basis mass fraction. Okay, class, are you following? Boleh ikut ke? Laju ke?
Boleh tak?
Okay, mass fraction close. Sama step macam tadi. And then make sure it's changed first Make sure dia dah tukar baru you key in the value. So double click empty dia. Okay, masukkan. Berapa ni? N-butane?
1.
1 because it is the one and only reactant. Okay, 1 and then enter. Okay, check dulu semua. It is already changed to mass fraction 1. Ni pun dah tukar mass fraction. Total must be 1 and then I click OK. Okay. So far so good.
So far so good.
Okay. Okay, next one. They're asking for temperature. Where should you put or key in the temperature? This is temperature.
Condition.
Okay, condition. Okay, so you just key in temperature. Berapa tadi temperature?
100K.
100 or 500? 500K. 500. Okay, make sure Okay, you nampak contoh di sini. Ini by default dia change pada degree C. Dia state degree C. So, tugas you adalah masukkan 500. Make sure you tukar di sini. Kelvin Okay. So, you nampak when you key in 500 but since they are calculating by default in degree C, dia tukar kepada 226.8. So, maksudnya you tahulah ini adalah value dalam degree C. Tapi don't worry because tadi kita dah set dia adalah in Kelvin. So dia adalah ni calculated based on degree C. Okay class?
Okay, doktor.
Okay, pressure berapa?
18 bar.
Pressure 18 bar. Oops. 18 bar. 18. Okay, sama juga tadi. This is ATM. Okay, by default. So you tukar pada bar. Mana bar tadi? Ni bar. Okay. Nampak tak? Bila you masukkan temperature and pressure, they have calculated the V over F value. Okay class? Boleh nampak
Boleh.
Boleh.
V over F equivalent to 1 and you know automatically it exists as vapor phase. So now, what is the question? They ask you to record the phase, mass density, molar volume. Okay, mana nak cari mass density, molar volume. Okay, kita tengok phase dulu. So phase is? Vapor. Okay. Lepas tu dia tanya apa lagi? Mass density, molar volume, molar enthalpy. Okay, kita tengok kat sini. Okay, molar enthalpy ada ini molar entropy, molar enthalpy negative 1.028. Ini cara you baca negative 1.028 times 10 to the power of 5. Positif 10 to the power of 5. Okay. So kalau you nak make you boleh check dia punya jawapan dekat next slide. You ada buka kan slide tadi? Ada buka slide tak? Kelas, ada buka slide yang ada exercise tu? Ada buka Okay, dia ada bagi jawapan in the next slide. So you boleh double check dekat situ. Okay, contohnya kita dapat molar enthalpy negative 1.027 times 10 power of 5. Okay, mass density berapa? Ada tak kat sini mass density? Okay, kalau tak ada, baru you pergi pada properties. Dekat sini lagi complete. Okay. Okay, kita cari molar density ni 0.4865. Betul tak? Kita check balik. Dia molar density. Dia tak tanya pun molar density. Okay, mass density. Okay, mass density. Mass density berapa? Ni 28.28. Okay. Okay, kelas boleh follow
Boleh doktor.
Boleh.
Okay, mass density lagi apa dia nak? Mesocyty done, phase done, molar enthalpy done. Okay, molar volume. Molar volume. Kat mana molar volume? Masih dalam properties ni molar volume 2.055. Okay. Lepas tu mass entropy dan juga viscosity. Okay, mass entropy and viscosity. Mass entropy. Ni mass entropy 2.832 dan juga last kali viscosity. Kejap. Okay, viscosity ni jangan tertukar. Kita ada dua. Satu viscosity 1.335 times 10 to the power of negative 2. Satu lagi kita ada viscosity index. Lain So, but this time dia minta yang dalam centipoise, CP centipoise. 1.335 times 10 power of negative 2. Okay, so far okay? Are you following?
Okay, Rasa.
Yes.
Okay, now we go to the next challenging question. What if this time you change the fluid package? Tadi you guna apa tadi? You guna paromycin. So now the next one, what if you change to SRK? Soft reddish form. Okay, and record all the properties yang kita dah mention in question 1. So soalan saya adalah, adakah you akan start all over again, setting all the component list, choose the right fluid package SRK, and then key in balik temperature, ataupun you boleh simply tukar saja?
Tukar fluid package je.
Betul, tukar. Macam mana nak tukar?
Pergi dekat properties, lepas tu pergi fluid package, masuk dalam basis.
Tapi kita tak set. Kalau you tengok tadi dekat condition, kalau you nampak kat sini dia ada fluid package. Nampak? So kalau you tengok fluid package ni, satu je ada. So macam mana you nak, ini basis one ni yang fluid package you want set, yang awal tadi, which is paromycin. So now here's how you do. You close dulu. Okay, yang tadi kan kita dalam simulation here. So you go back to properties. Okay, and then pergi dekat fluid package yang atas ni, jangan pergi dekat basis fluid package. Okay, and then click add. Okay. So bila you click add, class boleh follow?
Boleh.
Okay, so nampak you dah appear sebagai basis 2. So you choose lah SRK. Ni SRK. Then okay. So dah hijau ni dia converge lah. Maksudnya all the calculation and equation semua dah masuk. Okay. So macam tu je ke? Dah siap? Dah siap belum ni? You baru pilih ni. Adakah dah di-apply dalam stream belum? How to check whether it is applied or not? Anyone? Ini yang kita buat sekarang, you baru wujudkan SRK. But the question is now, how do you know that our stream just now has already applied this fluid package? Yang new fluid
Go
package.
to simulation.
Go to simulation, and then
Check in condition, lepas tu dekat fluid package. Should be basis number 2.
okay, good. So, okay, simulation and then double click stream. Okay, pergi dekat, saya tak masukkan lagi tadi molar flow rate sorry. Saya masukkan flow molar flow rate tadi selalu lupa lagi. Okay, 100 kan tadi. Okay, so pergi dekat fluid package and then you notice that dia ada 2. Okay, class? Are you following?
Yes.
Boleh Okay, so you just choose basis 2 dan you nampak semua berubah dalam ni Okay. So you boleh double check. Okay, let's look what is the phase now. If you change to SRK, so the phase is vapor, okay, 1. And then how about mass density and molar volume? Kat sini ada tak? Yang ada cuma molar enthalpy. Ni molar enthalpy negative 1.027 times 10 to the power of 5. Berubah tak daripada tadi? Okay, dia berubah yang ni tak berubah. Molar enthalpy tak berubah. Negatif masih sama negative 1.027 times 10 to the power of 5. Okay, what are the other properties yang kita akan check? Apa lagi? How about mass density and molar volume? Sini ada tak mass density, molar volume? Tak ada.
Properties.
Pergi dekat properties. Okay, mass density ada 27.83. So obviously it has been changed. Tadi berapa? Yang mula-mula tu 28.28 per Robinson. So if you change to SRK, it is 27.83. Okay, how about molar volume? Molar volume ada tak kat sini? Ni 2.088 molar volume. So obviously dia dah berubah And then mass entropy and viscosity. Mass density 27.83 and last one viscosity 1.334 times 10 to the power of negative 2. Okay, so far okay class? Are you following?
Okay, doktor.
Okay. Okay, if you understand those two, how about this time you change to ideal gas equation? Okay, cuba tukar fluid package yang baru. Fluid package yang baru maknanya dia akan jadi basis 3 lah. Ideal gas equation ada tak dalam tu? Kita tengok. Okay, go to fluid package and then add. So dia akan keluar. Okay, ada tak ideal gas equation? Jumpa tak ideal gas?
Tak jumpa.
Tak ada.
Ada nama lain tak daripada ideal gas? Known as NRTL. Non-random to liquid. Yang ni. Ni tadi. Ni. NRTL. So kena ingat NRTL by default dia adalah ideal gas equation. Nanti kan sampai ke sudah cari tak jumpa. Okay. NRTL non-random to liquid. Ada dalam slide notes. Okay, can you proceed? Check how to apply this basis 3 and then list out all the properties needed as requested from the question. Okay, saya bagi you 2 minit untuk 3 minit untuk observe. Okay kelas? Dah siap? Are you done?
Dah Doktor.
Boleh Okay, semua okay? Boleh buat Kelas, boleh buat?
Boleh Doktor.
Okay, so tadi kita macam saya tadi saya dah tunjuk how to change to NRTL and then go back to simulation, double click on stream. Under properties, make sure you change to basis 3. So the rest of the properties you boleh tengok macam tadi. Okay kelas? Boleh?
Boleh.
Boleh faham Okay, so saya tak tunjuk lah untuk yang 3 ni SRK, NRTL ni sebab properties yang you nak check sama saja macam tadi. Okay? Can I move to lab 3 before kita exercise 3 before kita break up? Boleh? Yang 3 ni challenging sikit. Can I still proceed?
Boleh.
Atau tak rehat je? Saya setri kot, 4 tu dia lagi susah sikit. Boleh? Boleh saya mula yang exercise 3?
Boleh.
So saya
Boleh.
Okay, good. Nanti lepas exercise 3 kita rest kejap. Okay, again go to file. Okay. Semua dah ready dengan screen baru? Saya bagi you seminit. Go to file, new and then case. So dia akan keluar balik, clear screen. Okay class, are you ready?
Yes.
Okay. So semua dah ready Okay, let's go back to the exercise 3. Okay. Okay, maybe I give you 3 minutes untuk you baca soalan apa yang dia nak. Okay, remember highlight what is the component list, what is the fluid package, what are the information they give you, and then what is the question they want to ask. Okay, 4 tu you kena tengok. Okay, I give you 3 minutes untuk observe.
Supaya kita bawa dia kenal Allah, kenal Nabi SAW.
Okay class, can we start?
Can.
Okay. Okay, boleh nampak skrin saya Okay, let's read the question. Okay, semua boleh nampak skrin saya
Boleh.
Okay, the question is, pump are used to move liquids. Okay, pump the function of the pump used to move the liquid by increasing the pressure of the liquid. Okay, so now you know that the phase is aqueous. Okay, okay, water at 120 degrees C and 3 bars. Okay, water. So it means that in this stream, it only you temperature and pressure 120 degrees C and 3 bars, okay, respectively, is fed to a pump that have 70% of efficiency. Okay, semua pump dia ada efficiency dia sendiri Okay, you are given flow rate of water 1800 kg per hour. Okay, see, this is the mass flow rate by looking at the unit, and its outlet pressure is 84 bar from pump. Ini outlet pressure bukan pressure drop. Okay, ni hati-hati Okay. Okay, so hati-hati ini adalah output pressure ataupun P out. So P out and the delta P is two different thing. Delta P adalah di dalam equipment. Okay. So kalau P out adalah P after you undergo the pump. Okay, maknanya P selepas pump Okay, the question is record the T out of from the pump for each of the condition. Okay, case 1. Case 1, you need to set the pump as 70% efficiency. Use PR, SRK and also NRTL respectively. Okay, so now you tell me what should I do in the first place. Okay, remember kita hanya ada water as our component list 100%. Lepas tu kita ada pump. Okay, so now the first step is that go to component list, go to add and then type water. Okay, macam tadi lah sama Okay, so far okay class, are you following?
Yes.
Okay, so what's next? So water saja dalam ni. Go to
Fluid package.
package, add, pilih yang first one apa, permission
Yes.
Okay. Okay, next simulation. Okay, semua boleh ikut sampai sini?
Boleh.
Okay, next macam biasa input stream. Okay, sebelum disebabkan dalam plan ni kita ada pump, so before you drag any of the equipment from the right hand side here, you have to make sure that the stream has been converged sebelum you tarik apa-apa, distillation column ke, reactor ke apa ke, pump ataupun heat exchanger, sama juga Okay, double click. Okay, again unknown composition macam tadi sama. Go to composition, water change to go to basis mass fraction. Okay, then double click mass fraction, make sure it is mass already. Water only, right? Betul? Is it water only? Is it water only?
Yes.
Okay, so 1, enter. So make sure it's already changed to mass 1. Benda yang sama ulang-ulang balik. Mass fraction, make sure total is 1, then click OK. Okay, and then unknown temperature. Go to
Condition.
condition. Okay. Temperature berapa tadi? 120 and 3 bars. 120. We say 3 bar. So ni ATM So tukar pada bar. Class, are you guys following? Boleh, you cuba buat sambil-sambil kita buat sama-sama So far dah sampai sini belum?
Dah.
Dah. Okay, lagi apa? Kita masukkan semua information dulu. Water okay, temperature 3 bars, okay, pump 70%, okay, pump tu nanti. Flow rate, okay, masukkan flow rate dulu. Saya selalu lupa masuk flow rate. 1800. Okay, ini adalah mass flow rate. So jangan tersilap masuk Atas ni molar flow rate, this is mass flow rate. Okay, make sure the unit is correct. Enter. Okay, what else yang saya ada tak tertinggal? Water, temperature, pressure, flow rate. Okay, cuma kita tinggal dengan efficiency of pump dan juga P out of from pump. Okay, and then find the T out. Okay, kita boleh check once you dah masukkan temperature, pressure and flow rate, you nampak converge. Okay class, are you following?
Yes.
Okay, bila dah converge, okay, baru you tutup, close. Okay, so you nampak biru gelap Tadi biru muda kan, kalau biru muda maknanya dia belum converge. Kalau ada dark blue maksudnya dia dah converge. Converge means all the information needed has already been keyed in. Dah siap, dah masuk semua Okay, now we need a pump. Mana pump Katalah you tak tahu. Okay, go to here, type pump. Okay, so you nampak ni simbol pump. Dekat sini setiap kali you drag, kita akan nampak nama equipment memang akan pop up. Okay class, are you still following?
Yes.
Okay, so once you type pump, you click the pump once and then you drag. Okay, dan seperti biasa bila you ada equipment, bila ada in mesti ada out. So you just drag the blue stream here. Masih stream yang main stream. Ni you boleh ubah boleh drag. Okay, nampak beza. Dark blue and then also light blue. Okay, light blue ni maknanya belum converge lah. Okay, so far okay? Class?
Okay.
Okay, so now the next question is how to connect this stream with the pump. How to connect? Okay, tadi one dah converge stream, input stream. So now double click on pump. Okay, dia akan keluar macam ni. Okay. Okay class, boleh follow sampai sini?
Boleh.
So now when it appear like this, you notice that at the left hand side dia ada connection dan dia ada parameters. Okay, so biasanya kita akan buat connection dulu. Ni under design kalau rating yang ni kita tak kacau selalunya. Worksheet, performance, ini kemudian Okay, biasanya kita akan untuk lab exercise 3 ni kita go to connection first. Connection, how to connect? Okay, kalau you tengok tadi stream ni, sekejap, boleh saya ubah tak? Okay, inlet, this is stream 1 right? So you go to inlet 1 and then yang 2 ni output, so go to outlet 2. Nampak? Dia dah connect. Okay, boleh? Class, are you following?
Yes.
Okay. Fluid package basis 1 yang kita dah set awal-awal tadi PR. And then energy. Okay, biasanya kalau pump dia akan ada energy lah. So kat sini kalau kita klik kosong tapi kita just namakan saja dia adalah Q1 contoh for example. Heat energy. So I just simply put Q1. and then enter. Okay, so bila enter you nampak ada stream masuk dekat pump ni, Q1. Okay, so far okay class?
Okay, Madam.
Okay, boleh. Okay, next they ask for what is the duty, heat. Tapi kita tak diberi kan? Betul. You are not given with the heat duty. Okay, cuma yang you ada hanya pump. Okay, efficiency of pump. How to key in. Okay, so under connection maksudnya you masukkan what is the inlet, outlet and also Q. So untuk duty you go for parameter, bukan duty sorry. Untuk efficiency, parameter. Nampak tak ni? Adiabatic efficiency. Boleh nampak?
Boleh.
Nampak.
Boleh.
Double click, masukkan 70, enter. Okay. So you akan dapat 70. Do we know any delta P? Class, do we know any delta P? Tak tahu kan? We don't know the pressure drop.
Tak tahu.
Okay, dia macam ni konsep dia. Bila yang masuk ni stream 1 dia adalah P1. Okay. Lepas tu dekat 2 ni adalah P out. Then apa yang berlaku dalam equipment, mana-mana equipment, dia adalah pressure drop, which is delta P. So since we don't know the delta P, tapi kita tahu P out. Is it right?
Yes.
So bila you tahu P in, you tahu P out, automatically you akan tahu what is the delta P here. So delta P ni kita tinggalkan dulu sebab kita tak tahu. Pressure ratio is not given. Q also you don't know. So you just leave it. Okay. Ni unknown duty Okay. So close. Okay. Dan you buka output stream. Okay, this is output stream. Saya kecilkan sikit. Okay. Okay, for output stream, this is P out. Yeah, stream number 2 tengok ni stream number 2. What is the information that we have untuk output stream? Kita cuma ada information of P out, which is 84 bar. Okay. Mari kita masukkan. Go to pressure. 84 bar. Change the unit. Okay, nampak? Bila you masuk, terus converge. Okay, so now what is the T out then? What is the T out? T out you boleh tengoklah dekat stream 2 ni. Stream 2 is the T out here. 1 to 1.4. Boleh dapat kelas?
Boleh.
Dapat 1 to 1.4
Dapat.
Okay. Minta T out saja kan? Okay. And then how about the second one? What happened to the T out if you change the fluid package to SRK? How to change it to SRK? Macam mana nak buat? Semua information masih sama, cuma kena tukar saja. Macam nak buat? Go to
Property.
okay, good. Sama macam tadi juga. Okay, and then pergi dekat ni make sure you click fluid package. Dekat sini baru you boleh add. So macam tadilah. Sama SRK. Okay. Okay, are you following until here?
Yes.
Okay, how about the rest? Is it okay?
Yes.
Okay, so you just add the fluid package SRK. Now how to apply to the system? Go to
Simulation.
simulation. Atau stream mana you nak buka tadi? You kena pergi pada input stream sebab inilah dekat input stream yang kita set everything untuk fluid package. Go to stream, double click. Yang ni dekat sini under properties. Sama, under condition yang tadi Go to this one,
Basis
change to basis 2. Okay, converge. Lepas converge, baru you close dan you boleh check what is the output temperature here. Oh, sorry, ni saya tekan pump lah. Okay, stream 2 So now the temperature has changed slightly to 1 to 1.2. Boleh dapat kelas?
Dapat.
Dapat Okay, kalau you tengok slide ni, ada jawapan ni kan. Okay, cuba you tukar pada NRTL. Your fluid package, can you do it? Saya bagi you 2 minit. Senang je kan? Ubah semula. Yang ni you sentiasa boleh ubah dia punya stream ni. Contohlah saya nak pergi ke atas sikit ke, dia akan jadi macam tu, nampak? You ni pergi ke atas ke bawah. Dia sentiasa boleh bagi cantik sikit lah dia punya flow. Contohnya macam ni Okay, so I leave it to you for untuk properties, untuk check balik full package. Okay, add the new one, NRTL. Okay class, are you done?
Yes, Doctor.
Okay, so tadi saya dah ubah NRTL. Go back to stream, make sure you change to basis 3. Okay, close, double check your stream 2. So finally you will get the T out as 1 to 1.6. Okay, semua dapat sampai sini 1 to 1.6?
Dapat.
Right. Okay, just one more thing before we break. What if now you change the efficiency to 40%? You nak tukar efficiency ni. Tapi saya tengok semua sama je tadi kan? Robinson, SRK, NRTL. Now you just need to change the efficiency saja. Yang parameter lain, temperature, pressure, flow rate, P out semua sama. But now you need to change the pump efficiency. So how to change this pump efficiency? Okay. Okay. Okay, how to change this pump efficiency? Because you always adjust the efficiency at the equipment, right? Okay. Tapi maksudnya bila you nak cuba ubah pada equipment, apa-apa pun you kena set dulu fluid package at the beginning. So now saya akan go back pada PR package 1. Stream 1. So saya pergi pada condition tadi. So kalau you perasan tadi kita dah set kan, kita ada 3. So I will go back to the pair Robinson. Make sure it converge. Baru you tutup. And then go to pump. At the parameter change to 40%. Okay. Class, are you following?
Yes.
Okay, lepas tu baru you tukar, baru you check pada what is the T out. Make sure ni pun dah tukar basis 1 1 to 3.5. Okay, so conclusion, you nak tukar apa-apa dalam equipment mesti kena double check dulu dia punya fluid package at the input stream. Okay, kalau dia punya fluid package sama, no problem. You can just keep changing the efficiency. But once you want to change both efficiency and also the fluid package, so the fluid package will come first. apa-apa pun mesti set fluid package dulu. Okay kelas? Boleh faham ya?
Boleh.
Faham.
Okay, so now this is the output temperature kalau you guna Robinson. Okay, so can you repeat for SRK dan juga NRTL? I give you 2 minutes. Sangat simple. Sebab tadi kita dah set pump tadi. Parameter dah 40%. So you just keep changing sajalah untuk SRK dan juga NRTL. Okay. Sebab untuk yang case 40% pun dia minta you apply full package yang sama. Like Robinson, SRK, NRTL. Okay, I give you 2 minutes maybe. Okay class, are you done?
Yes.
Okay, so let me just do very quickly. Okay, let's say saya nak tukar pada, oh sorry, pergi pada SRK tadi. Double click one, so I change to basis 2, converge. Okay, and then I go to the T out. Make sure it is basis 2 also. So 123.3. Okay, berubah tak tadi? Okay, oh sorry. Okay, and then last one. Okay, close back. So you go to again input stream, change to NRTL basis 3, converge, close, double click to, and then make sure it is basis 3 as well. So you have 123.8 degrees C. Okay class? So far okay? Are you following?
Yes.
Okay, okay. I give you 10 minutes break. Okay, nak break lama-lama pun takut tak sempat nak habiskan exercise 4. Hari ni kita dapat buat sampai exercise 4 saja. Okay, and then kita akan come back pada 10:30. Okay, boleh? Meanwhile, saya akan share screen untuk soalan exercise 4 dulu. So that, okay, 10 minutes break Okay kelas, boleh kita mula? Satu lagi exercise lepas tu nanti kelas dismiss pukul lagi setengah jam lagi. Kelas boleh mula sikit lagi? Sambung sikit lagi?
Boleh.
Okay. Okay, in exercise 3 we deal with pump. So pump function dia adalah untuk move liquid. Okay, whereby untuk exercise whereas untuk exercise 4 kita deal dengan compressor. So the function of the compressor is to move the vapor. So lain function liquid pump dengan compressor lain Pump to move liquid, compressor to move vapor. Okay, since the word compressor ni means macam kita compress, biasanya compress daripada vapor ke liquid. Okay, but some of the cases bila you put the compressor, you move the vapor, tapi yang output from the compressor juga masih vapor phase. Dia actually depend pada pressure berapa yang ada dalam compressor tu. Kalau the pressure is enough to convert from vapor to liquid, so it become liquid. Otherwise, kalau pressure dia macam tak banyak sangat changes, maybe at a certain pressure drop, so the vapor yang masuk, yang keluar tu juga masih vapor. So it depends on the pressure, okay? So that is all about the function of the compressor. Okay, compressor are used to move vapor, okay, by increasing the pressure of the vapor. A mixture of natural gas. Mixture, so mixture means you hanya ada satu stream, okay, which consists all natural gas, C1, C2, C3 ni lah, methane, ethane, propane, butane, pentane, semuanya dan juga kita ada C7 plus, okay, at 100 degree C and 1 bar is fed into compressor which has the efficiency of 60%. You are given flow rate 100 kmol per hour, okay, molar flow rate and P out of the compressor is 5 bar. Again, use PR, Peng Robinson as the fluid package, determine what is the T out. Okay, create hypothetical component. Okay, yang create tu nanti dulu. Okay class, can you help me to start with the first step, component list? Boleh cuba buat? Okay, kita start dengan okay, kita pergi go to component list, add, macam mana add, okay. Dalam soalan dia bagi you C1, C2, C3, okay. You kalau you tak tahu nama komponen, no problem. You boleh just type saja. Contoh C1. Okay, sorry. Kalau C1 dia akan keluar lah. Okay, so C1 simbol dia adalah methane. Okay class, are you following?
Yes.
Okay, so you click and then you add. Okay, and then next C2. So jumpalah C2 and then you click ethane, you add. Okay, boleh cuba buat sampai NC5. Boleh cuba buat? Saya bagi you 3 minit untuk masukkan C3, IC4, NC4, IC5, NC5. Sampai NC5 dulu masukkan. Okay, teruskan Okay, kalau untuk IC4, you type saja I C4. So nampak jumpa lah. Ini IC4 adalah ibutane. Okay class, are you following?
Yes.
Okay, so teruskan kalau ada NC4, type NC4. NC4 repeat untuk C5. maintain Okay class, are you done until N pentane?
Yes. Good.
Yes.
Okay, untuk yang NC6 ni dia pelik sikit sebab sepatutnya okay, saya type NC6. Okay, kalau you type NC6 dia AL kat belakang ni mana hexanal. Sepatutnya yang ni adalah methane, ethane, propane, butane, pentane dan hexane sepatutnya. Okay, N-hexanal. Okay, cuba saya enter dulu. Okay, baru jumpa N-hexane. Okay, N-hexane ni sepatutnya betul Okay, saya add. Okay, katakanlah case macam ni you tersilap masuk equipment. Tersilap masuk component list. Macam ni nak buat, you go to hexanal. Okay, and then you remove. Okay. So dia
Dia tak share screen ni dia lagi.
alamak, ya ke? Alamak, sorry. Kenapa tak ingatkan tadi? Kejap. Sorry sekejap. Okay, sekejap saya remove N-hexane. Okay, boleh nampak? Boleh nampak?
Nampak dah.
Okay. So again saya repeat macam mana nak buat untuk N-hexane tadi. Okay. Sepatutnya dia adalah NC6. Okay, tapi apa yang keluar adalah NC6AL. Tapi kalau AL ni mana hexanal. Tapi kalau you tengok sini, semuanya adalah methane, ethane, propane, butane, pentane. Sepatutnya selepas pentane adalah hexane. So, kalau you pilih N-hexanal tu tak betul lah. Katakanlah saya contoh saya contoh je. Okay, setelah saya double click dia masuk N-hexanal. Lepas tu barulah saya nampak hexane. Ada tak hexane kat sini? Saya type. Ni sepatutnya N-hexane ni. Okay, saya klik dulu. Masukkan. Okay, contoh you dah masukkan semua. Katakanlah tiba-tiba dalam satu case you tersilap masuk component list. Maknanya reactant you tu silap. So how to remove? You just go to N-hexanal and then click remove. Okay. Okay class, are you following? Class, are you following?
Yes.
Okay. Okay, last component yang you kena masukkan adalah C7. C7 plus ataupun kat sini dia tulis star C7. Okay. Sekarang ni you kena masukkan C7 star. Okay, C7 star ni dia kalau you type dia tak ada dalam ni Okay. Contoh katakanlah you dah masukkan semua. Tiba-tiba you ada satu component list yang memang tak ada dalam data bank. Data bank HISIS. So apa you perlu buat? Okay, kat sini you guna C7 ni tak ada dalam bank ni you boleh cari. Okay, you go, ini kan pure component. Okay, pure component maknanya yang data yang dah exist dalam data bank. Okay, you go to hypothetical. Okay, ada dua satu hypothetical, satu lagi hypothetical solid. Solid ni nanti kita buat dalam lab 4 nanti ke lab 5 Okay, yang ni kemudian lah. Okay, sekarang saya nak ajar hypothetical sahaja. Okay, klik hypothetical. Okay, bila you klik hypothetical, okay, dia automatically akan keluar hypo group 1. Okay, so yang ni you tak payah ubah, dia automatic. Okay, method. Method ni, okay, satu kita ada create and edit hypos, satu lagi create a batch of hypos. So disebabkan you nak masuk hanya satu saja component, You tak boleh pilih batch. Kalau batch nanti dia keluar banyak. Okay, so you just pilih yang first ni, create and edit hypos. Okay, are you following? Class, are you following?
Yes.
Okay, untuk type ni biarkan default base properties. Okay, so macam mana nak masukkan C7 star tu? Okay, next kita ada dua button ni. Satu new hypo group, satu lagi new hypo. Okay, jangan masuk group. Group ni dia akan keluar banyak. Okay, so kita masukkan new hypo saja sebab kita ada satu komponen. Klik hypo. Okay, so dia akan keluar interface yang ni. Okay, so far are you following?
Yes.
Okay, so how to insert the 7 star name? Okay, you double click pada yellow color ni, hypo. Okay, so dia akan pop up window ni. Okay, so dalam ni lah you boleh double, bila keluar pop up window ni, you boleh edit nama tu pada sini. Nama dia dia C7 star kan, saya buat sorry, C7. Tak, sorry. Terbalik, C7 star. C7 star. Okay. Sebab bila saya buat star C7, dia recognize star saja. Okay, so saya terbalikkan dia C7 star. Okay, kelas? Boleh follow?
Boleh.
Enter. Okay, so bila you close, you nampak C7 star. Okay, kelas? Boleh?
Boleh.
Okay. So now, apa lagi yang dia bagi dalam soalan? Okay, kita dah check. These are all the component. Refer slide note temperature 100 degree C, 1 bar, fat 60% efficiency. Okay, ni nanti dulu. Flow rate nanti dulu. P out pun nanti dulu. Use PR. Okay, kita yang ni belum pilih lagi. Okay, ni ayat yang last. Create hypothetical component. Okay, sebab dia dah bagi tahu hypothetical C7 star. Use normal boiling point 110 and molecular weight of 172. Okay, kat mana nak bubuh properties ni, boiling point of C7 star. Okay, you perasan kat sebelah ni ada nama boiling point dengan molecular weight. Nampak tak?
Yeah.
Okay, masukkan value boiling point 110, make sure it is degree C. Enter. And then molecular weight of 172. Enter. Okay. Sebenarnya step ni saja untuk exercise for step ni saja yang lain sikit. Yang lain semuanya, step yang seterusnya semua sama macam exercise 1, 2, 3. Okay. Okay, class, are you following?
Yes.
Okay, so after normal boiling point and molecular weight, you nampak tak ada liquid density? You boleh drag sorry, you pakai cursor drag kat bawah ni. Okay, you boleh nampak liquid density, TC, PC, VC, ni semuanya empty. Okay, so okay, bila saya klik, dia akan auto calculate. You boleh tengok dia dah already fill out. Liquid density, TC, PC, VC, okay, eccentricity. Okay, kelas? Boleh sampai sini?
Boleh.
Okay. Okay. Still remember, TR is equivalent to T over TC. TR okay, T over PC, betul?
Betul.
Okay, so maksudnya temperature unit dia T, dia adalah reference temperature. Is that right? Dah lupa dah equation thermodynamic. CPP, kita belajar kan? TR equivalent to T over TC. Okay, so you really need this TC PC, okay, untuk calculate T and pressure later on. Provided that you know what is TR and also PR. Okay, now dah siap. Lepas tu nak buat apa? Add lah, boleh add lah. Okay, so you click C7 star add. So you dah nampak kat sini bawah sekali C7 is already added. Okay, boleh?
Boleh.
Okay, semua dah add Okay, before you buat next step after component list, choose the fluid package, do the simulation. Okay, buat fluid package dulu. Add. Kita guna PR. Okay. Then simulation. Okay, saya bagi you seminit untuk sampai sini. Ke semua dah siap? Dah, okay. So first thing, sebelum start apa nak buat? Dah tekan simulation ni. What is the first thing you should write?
Stream.
Okay, good. Okay, stream. Okay, double click. Unknown composition. Unknown composition. So, nak pergi kat mana? Unknown composition. Pergi dekat composition. Is that right? Betul kelas? Composition. Is that right? The composition?
Betul.
Okay. So untuk composition, okay, nampak ini adalah mole fraction. So bila you go back to the question, the component given is already in mole fraction. So you tak boleh tukar kepada mass fraction. Macam exercise 1, 2 and 3, because mole fraction is not given. So by default we change to mass fraction as the basis. But this time, since it is already mentioned, it is a mole fraction, so you tak boleh tukar.